as you know, we are in bivariate data analysis techniques, being particularly numerical analysis techniques in 3 different categories. First category, where we have 2 qualitative variables. In order to see the association between those 2 qualitative variables, we use a statistic called chi-square. And the second case, where we had 1 qualitative variable and 1 quantitative variable, we use t-statistic as well as ANOVA, for which we calculate every statistic depending on the number of categories our qualitative variable has. And then the third case, where we have 2 quantitative variables, we use covariance, correlation, and linear model. We have seen how we calculate all these statistics in R. Next, we will use a data set with few observations in order to see how actually using pen and paper we can calculate data.
Let me consider this data set with 5 observations, and I have collected data on gender, major, age, and GPA of 5 students. Let me start with the first case where we have 2 qual, and for that I consider, of course, gender and major. In order to study the association between gender and major, we need to have the chi-square statistics, which is the sum of observed joint frequencies minus expected joint frequencies squared divided by the expected joint frequencies. Now, as you can see, to calculate the chi-square statistic, we need to have the joint frequencies as well as the expected joint frequencies. And in order to have the joint frequencies, I have to first construct the two-way table. Let me construct the table for major and gender. As you can see, in the major we have business, we have IT, and we have political science. These I put in the columns, and then in the rows I put females and males. Gender. So now we go ahead and calculate the joint frequencies. First, female in business. Now let's see how many female students we have who are doing business. 1 female business, 2 female business. So that means the joint frequency of female in business is 2. IT and female. Do we have female who is doing IT? No. 0. Female in political science, 1. For male in business, 1, which is this one. Male in IT, 1, which is this one. And male in political science, we have no student. Now these 6 numbers which I have calculated here, these are joint frequencies. In order to have marginal frequencies, let me start with marginal frequency of business. 2 plus 1 is 3. Of IT, 0 plus 1 is 1. Of political science, 1 plus 0 is 1. The same way I can calculate the marginal frequency of females. I have to add 2 plus 0 is 2 plus 1 is 3. Males, 1 plus 1 is 2. That is the marginal frequency of males. The grand total is the sum of the marginal frequencies. 2 plus 3 is 5, same as here. So the grand total, which is 5. In step is, if you see in the formula of the chi-square, not only we need the observed joint frequencies, which are 2, 0, 1, 1, 1, and 0, we also need the expected joint frequencies. And for that, I have to use the formula. For each one of these joint frequencies, we have a corresponding expected frequencies. Expected frequency, let me start. Expected frequency for females in business. And that's nothing but this marginal frequency, which corresponds to this, and this marginal frequency, 3 times 3, divided by the grand total, which is 5. Now 3 times 3 is 9, divided by 5, which is 1.8.
Okay, so I write the joint frequency, the expected joint frequency here, 1.8. The same expected frequency for female in IT. This is this marginal frequency times this marginal frequency, which is 1.3 divided by 5 is equal to 3 divided by 5, which is 0. I continue calculating the expected frequency for female in political science, and that's nothing but this marginal frequency times this marginal frequency. 1 times 3 divided by 5 is equal to 3 divided by 5, 0.6. So I write here, this is 0.6, this is also 0.6. The same I do for the males. Expected frequency of males and business, this is equal to 3 times 2, that is here, 3 times 2 divided by 5, which is 6, divided by 5, which is 1.2. So I write here 1.2. The expected frequency of males in IT is equal to 1 times 2 divided by 5, which is 2 divided by 5, which is 0.4. So I write here 0.4. And the expected frequency of males in political science is nothing but 1 times 2 divided by 5, which is again 2 divided by 5, which is 0.5.
Having all those observed frequencies as well as expected joint frequencies, I can plug in these numbers in the formula and calculate chi-square. So therefore, chi-square statistics is equal to, first, observed joint frequency is 2 minus 1.8, which is the expected joint frequency. Everything is squared divided by 1 point plus. Second, observed joint frequency is 0 minus 0.6. Everything is squared divided by 0.6 plus 1 minus 0.6 squared divided by 0.6. So these are the observed minus joint frequency squared divided by expected joint frequency for females, and I continue this for males. So 1 minus 1.2, everything to the power 2 divided by 1.2 plus 1 minus 0.4, everything is squared divided by 0.4 plus 0 minus 0.1, everything is squared divided by calculating them all, I get 2.222. I hope you do not have any problem calculating all these numbers. This is the value of the chi-square. The chi-square statistics is 2.22. But we don't know how much is the p-value for this. What is the p-value? In order to find the corresponding p-value for this chi-square statistic, we need also to find the degrees of freedom, or df. Degrees of freedom is equal to the number of columns minus 1 times the number of rows minus. That's equal. How many columns do we have? We have 1 column, we have 2 columns, we have 3 columns. This is 3 minus 1 times how many rows do we have? We have 1 row, we have 2 times 2 minus. This is equal to 3 minus 1 is 2, 2 minus 1 is 1, which is equal. Now, with these two values, the value of the chi-square statistic and the degrees of freedom, which is equal to 2, I can find the p-value. In order to calculate the p-value, we use an online calculator of the p-value, where I need this chi-square statistic value as well as the degrees of freedom. I go to the website, I enter here the p-value, which is 2.22, and the degrees of freedom, which is 2, and you ask the calculator to calculate the p-value for you. Now you can see that the p-value here is 0.329. So you're coming back and write that the p-value is 0.329, which is of course much bigger than 0.01. There is no significant association between gender